This is Ali Reza, and in this episode we will start working with tile entities. Very basic, not diving in for time being, but we add tile entity package, and in here we'll add new classes for TE factory, for tile entity factory, and another one for TE generic J block. Okay? Now, this guy will extend, of course, tile entity and implements inventory. What does that mean? Well, this means that this tile entity will have inventory in itself, okay? And of course, by doing that, we need to implement lots of methods. Wow. Yep. Okay, first we need a public TE generic block. This is the constructor. It has no operation. Now, as any other tile entity, we will have to, we will have to add two methods. So override write to NBT, and we just name this guy to NBT tag compound. Yeah. And here we just call the super, and again override read from NBT and rename this guy to NBT tag compound. So let's start organizing it. So this is NBT read and write. We close the region and all these other stuff inside another region that we'll call inventory. Okay, now get size inventory returns 0, get stack in a slot, we rename it to, no, not of that, slot in. What the hell? Okay. Decrement stack size. Let me double check because things are a bit different here. Huh. Yeah. So this is I, this is J, and again we return null, get stack in slot on closing, this is index of course, we return again null, set inventory, in here we will say I, and this is item stack, nothing, get inventory null, has custom inventory name. Well, we say it to false, yeah. Get inventory stack limit is 0 as but is usable by player. This is player and is false. Open inventory, close inventory is item valid for slot. This is I, and this is item stack, and return false. So by default, That is our tile entity generic block. But now, remember, create new tile entity. We were returning null. Okay? We return new te generic jblock now. Okay? Now for our factory, we have lots of things to do. Remember, our factory is extending a block that has tile entity, so by default this guy is having tile entity by itself again. So we say override our create new tile entity, and here we say return a new te generic block. For time being, now I need to add a new tile entity. That's te factory. Okay, te factory extends our te generic j block, and by that I'm just, oh, this is a mess. It will become a mess. Yeah, and by that we are extending another tile entity, but again implements inventory. No, sorry, it has the inventory there. So we need to add stuff. Of course, first of all, we say public te factory, and we just say nothing in it. That's empty for time being. Then we say insert override method right to nbt tag compound. After that we will add stuff, and again override method read from nbt, and again tag compound, but at the end we will add stuff. Now we will override something here called update update entity, and this will happen every tick. Okay, for those that are familiar with Unity, this is just the update method from Unity. And then we will add something here, and that is another override, and this is receive client event, and it has two parameters. One is ID, and the other one, no, enter. The other one is value. Okay. The next methods are all about inventory again. So insert override method get size inventory. Okay. Now here we need to change stuff. We will add an array of item stack. So item stack array, and we call it items. Okay. Yeah, items. Thank you. In the constructor, we say this dot items equals new item stack of the size of 150. So basically we are letting this tile entity have 150 different item stacks. Okay. Now let me see what I need to do. Yeah, here we return items dot get dot length. Okay. The next one, override method, is get stack in a slot of slot in, and which returns simply items of the slot in we gave it. Then another one is decrement stack size. Now this is interesting. We say item stack. We define an item stack equals to get stack in a slot of I first. Okay, we want to see what is in that slot. Then we check if it is not null, because if it is null, we don't have anything to do. But if it's not null, then we say if item stack dot stack size, okay, is less than or equal to j, okay, then we say set inventory stock contains of I comma null. Okay, we are decrementing it, and let me rename this guy to count. This will make more sense. Else means that our item stack has has greater count. Here, let me tell you this. We are telling this that, hey, you decrement this amount from the item stack. So we check if the amount we have is less than or equal to the amount we want to remove, then we simply put it as null because there's nothing left. But if we have more, so item stack equals to item stack dot split stack count. So it will remove this amount from the item stack. Then say this dot mark dirty. That will cause the tile entity to update itself. At the end of everything, remember we need to return an item stack, so we return item stack. Now here it maybe became a null, or it will have the new amount. Another method, alt insert. Get stack in a slot on closing I. We say again item stack equals to get stack I. First we get the stack. Then we say set inventory slot contains I comma null, okay, and return item stack. That's simple. What is this method? Well, we get the stack in a slot on closing the title entity's inventory. So we just want to have nothing in there. Okay. Then another one of those overrides, and that's set inventory slot contains index of I and item stack, and we say items of I equals to the item stack we gave it. Okay. Then we say if item stack does not equal to null, and item stack dot stack size is greater than get inventory stack limit. So if we are still having items and we are above the stack limit, item stack dot stack size equals to get inventory stack limit. What we are doing. And finally, we mark this as dirty. We are saying that first, the items of the index is equals to the item stack we are assigning. Okay? Then we say if item stack does not equal to null. So if we have the item stack and the stack size is greater than the limit that we can accept, then we say, hey, item stack that stack size equals to get inventory stack size limit, and I think this should come here. So we first make sure that the stack size is proper for the item slot, and then we put it in the slot and mark it dirty. Another one of those methods, and that's get inventory name. This is simple. We return a string. We say factory inventory. Okay. Another override method, get inventory stack limit. Now, this is interesting. Be careful about this guy. For example, I put return 64. If I put 1 here, okay, we will come to this later when we are defining slots inside the inventory container. But if I put 1 here, basically I'm telling my containers that, hey, the whole system can only accept one and one only item. This will cause a bug later on when you are trying to shift click items in and out, and you will see that your items inside the inventory gone, they poofed away, but you only just get one item in your slot because you forgot that, hey, I had put this guy here as 1. So by default I will put 64 here. That's the biggest stack that we can in Minecraft at all. That would make me safe there. Then another override, yeah, having inventories are just huge overrides, is usable by player, and we say, okay, we return if player dot get distance squared, because that's faster to calculate, x squared plus 0.5f, comma, y chord, comma, z chord, okay, if this is less than or equals to 64. Basically, I'm telling that, hey, if I'm 64 blocks away from this tile entity, I should not be at all cared about the tile entity's interaction with players. Okay? Then, next one. Is item valid for slot? Well, here we say if item stack dot get item equals to items of I, then get item. Okay, so how are we validating the items validation for slots? We say if the stack that we have is equals to the item inside the block container inventory, sorry, not container, inventory. Then another override, and that is open inventory, another override, close inventory, another override, and that has custom inventory name. Okay, so I remember I had some comments here. Wait 1 second. Uh, where was that? Hmm, has custom inventory name. Return false, whatever. Okay. So, yeah. And all of these are related to our inventory. So, till here, they are related to inventory. Okay. And I can, bam, close it. This is NBT. NBT. Okay. And bam. So now I can go back to my factory, and here instead of generic I will say TE factory. Okay. And of course optimize new parts. There we go. So are we finished? By all means, no. We are just implemented the very base of having a tile entity on our factory itself. Let's start from factory itself first. We are adding stuff. We are adding a method for on block activated. Wow. Yeah. So this is word, this is X, this is Y, this is Z, this is player, this is side, this is sub X, this is sub Y, and this is sub Z. Yeah, crazy, isn't it? Okay, what do we want to do first? At the end of the method, we want to return true, nothing more. But before that, we say if word that is removed is false. Remember, word that removed means the client side. We want to work on the server side. So if word removed is false, then we say if player dot get current equipped item does not equal to null. Then we say if player dot get current equipped item dot get item does not equal to null. Okay. Then we say if player dot get current equipped item dot get item instance of our digital vent. Okay. Then we say if player dot is sneaking, we want to do something else, we want to do something else. So what we do want to do is for time being saying that open the GUI. If we are sneaking, if we are not sneaking, we want to rotate the factory. Okay? What is this method doing? Well, first of all, we say if we are on server side and if we are having anything in our hand and that thing that we have in our hand is an item and that item is digital WAN. Then we check if we are sneaking, we open the GUI. If we are not sneaking, then we rotate the factory. Okay? So let's play the game. Okay? So here we have a factory. Okay? And empty my hand, going to my mod, digital WAN. Okay? So I will right click with empty hand. Nothing will show in the debug. If I shift click, nothing will show. If I rotate with digital WAN, you see a message going rotate the factory. If I shift click, shift right click, nothing will happen. Why is that? Why is that? Well, hmm. Okay. We don't see that message. That is interesting. Rotate the factory. That's okay. But if I shift right click, I'm not getting the... we are getting the rotate factory, but here I'm not getting the message. Huh. Okay. Did I forget anything? No. Go to creative and destroy this block. So let's go back and take and have a look here. If I put down my item, sneak, right click, nothing, right click, yeah, but I forgot something. Yeah, that's the reason. Inside our items, tools, digital WAN, yeah. Okay, items, tools, digital WAN. This got me a few days to figure out, and thanks for people inside the uh, Minecraft Forge channel. We have a method here called does. That is not does. Does sneaking bypass use. Okay. We return true. What this means is When we are sneaking and right-clicking, we should get interaction with items. Now if I play, and that really took me a few days because I was constantly sending back my code from where was it, factory here. I was sending this part of the code time and again, and the people said, hey, this should work, that is okay, that is properly programmed, but yeah, this one line is all digital and will solve the issue. You'll see why. So as before, right clicking, rotate the factory. Shift right clicking, hey, open the GUI for me. Okay, and there we go. So in factory we have few more methods to add. First of all, we will what I'm doing, override another method, and that is break block. Okay, and this method of course asks for word x, y, no, and z, and then block, that is the block, and finally metadata. Okay, before calling the super, we ask for tile entity of entity equals world.get tile entity in x, y, and z. Remember, when I was speaking about tile entities, I said tile entities are classes that bind to the block, to a singleton block. So factory itself is a singleton, but we told him in this line that, hey, this singleton is binded to an instance inside the game called tile entity. How we get the tile entity is like this: tile entity word that get tile entity as certain coordinates. Okay, now we check if the entity is not null. So if we have any entity there and the entity is instance of, now we could use the factory here, we could use everything, but in this special case we are interested in its inventory. Okay, so if you have an entity and if that entity has inventory, then we say inventory equals to, of course, casting to inventory of the entity. So this is just casting inventory to its proxy format so that we get it easier to work. Then for into I equals 0, I is less than inventory dot get inventory, get size inventory, semicolon I plus plus. A for loop, we say item stack equals to inventory dot get stack in slot. No, not this one. Dot get stack in slot on closing of I. Okay, so we are saying that, hey, we are breaking the block, so we are closing all the inventories in that block. So please give me back the stack that is in this index of the file and set it to null. Remember, that was one of the things we added in the tile entity factory here. If it'll take a look, here, get the stack in a slot on closing. First we got the stack and we return it, then in that index we set null. Okay, so we are nullifying that stack. Now we say if the item stack that we got from this call does not equals to null. So if we got any kind of item stack, we add float spawn x equals to the x we gave it plus var dot rand dot next float. Same thing for y and for z. So what we are doing, we are defining a random point around the player to spawn this item stack that we took from inventory on the floor. Okay. Sorry. So we say entity player, entity item dropped item equals new entity item of var spawn x spawn y spawn z, and what we need, item stack. This will spawn the item stack inside the var. Okay, then we say float multi equals to 0.05f, because honestly next float will be a huge number. Sorry, this won't spawn. This line won't spawn, but it makes an entity to be spawned, and these numbers are huge, so we multiply it with a very small number. So we say dropped item that motion x equals to minus 0.5f plus var dot random dot next float, and still we are getting a big number, so we are applying with multiplying with multi. Sorry. What did I do? Control C, Control V for Y and Z. So this is motion Y, and this is motion Z. And for motion Y, I use 4F. Okay. And yeah, then finally we say var dot spawn entity in the var, and that is dropped an item. Okay. This is the simplest way of dropping items from inside an inventory inside the var. It will just stack them on top of each other. You could, break them, blah blah. But this is the easiest way. And of course it won't work anyway because I have no slots and no inventory in factory yet. So there is nothing to see here, but we want that. Okay, next. I will add that part later. We will come to this factory class much later time because we already set all the things we need inside here, just the only thing that we need to do. So I will add a to do, open the GUI and to do, or rotate the factory. Okay, but at the end here I will say to do stuff related to custom model, because we will have a custom model for this factory later on. And well, it's near 40 minutes. I think this is a good wrapping up for our factory and very base implementation of inventory stuff inside the tile entity. See you guys in the next episode.